Hello, and welcome to the very first episode of the IOA Video Bulletin. Sorry, slower, please. Thanks. I'm Rich Keeble, and I'm your host, bringing you the latest research developments and news on acoustics. Sound good? Let's take a look at what's coming up. Next, Dr. John Lincoln, author of the Sound Economics Report, tells us how acousticians will recover post-COVID-19 pandemic. Ben Fenech tells us why quiet is better for our health. Find out how quiet lockdown was with the Quiet Project. Dr. Mark Holderried tells us about his groundbreaking research. Gianluca Mamoli tells us how normal materials can be used to redirect and transform sounds. Find out how the Institute of Acoustics has responded to the COVID-19 pandemic, and keep up to date with the latest developments in acoustics with Sound Flash. So, here to tell us about the effect the COVID-19 pandemic had on the acoustics industry is Dr. John Lincoln, the author of the Acoustics Sound Economics Report. Hello, John. Hello, John. It will put through the call. Thanks. Hello, John. Now, for those that haven't read it, what was the Acoustics Sound Economics Report and what did it teach us?
Well, this was a piece of work we undertook last year to try and, for the first attempt, put a size on the acoustics industry in the UK, the direct size. Like many other enabling technologies, that's often buried within companies, so it's very hard to access its size. So this was an attempt to put a figure on how big the industry was for the first time, how many people it employs, and what the productivity was. And the simple answer was it's a £4.6 billion industry employing 16,000 people in about 750 companies thereabouts, with a magic figure for the gross value add, which is a measure of productivity of around £65,000 per employee, which is significantly above the UK manufacturing average.
And what have been the effects of the pandemic on the acoustics industry?
So one of the most interesting things we got from this survey was exactly how many companies are still able to keep manufacturing throughout the pandemic. And I think the conclusion is the direct impact has not been as severe as some people have feared. It is certainly different between the service sector of acoustics, acoustic consultants, who obviously need access to site, especially in the construction industry, and the impact on them has been more severe. But within those people manufacturing acoustics products, 80% of those people have been able to keep manufacturing throughout the pandemic, keep shipping products, keep taking orders, and keep operational. Of course, many of those people have sent a great number of people home, but they are able to keep the critical staff in their factories and able to keep producing product. And I think that's a really upbeat assessment. We've not had to shut up shop and send everybody home and put the industry on ice for 3 months.
So what can acousticians do to recover from the pandemic?
The impact on many had been a slowing of the order pipeline. So it's taking a lot longer for many people to get from initiating an order and inquiry from a customer to closing that and putting that into production. That's a problem because if you stretch your pipeline too long, that reduces the number of orders you can ship. And that gives a real hint about where people in manufacturing and industry should prioritize, which is to revisit your customer journey and see how you can re-engineer it for this all-digital remote world where we can't capture new customers at a trade show, we can't go and visit them to close out a lead. How can we re-engineer that journey using online tools to get new customers in and process them through until they're placing orders? That's really important and very much around the industrial community. On the other side, there's the research community. And I think in research, one of the most important things to note is that research is very hard to make up for lost time. Research is not something where you can throw additional resources, even though they're very gratefully received, and suddenly make innovation happen faster. And so one of the things we would really much encourage in the university sector is to get researchers back into laboratories, get them back researching.
Thank you, Dr. John Lincoln. Now, we know noise can be bad for our health, but can sound also be good for our health? To tell us more is IOA Council member Ben Fenech. Hi, Ben. Hello, IOA Council member Ben Fennick. So how can sound improve our health?
So in the last 30 years or so, we've seen a big improvement in our understanding of how noise affects health. But we've also seen a growing movement looking at opportunities for health improvement from looking at sound in a holistic way. And of course, there's the whole domain of music and music therapy. Perhaps that's a topic for a future bulletin. But if we look at the sound in the environment we live in, perhaps the easiest example is nature, green spaces. The physical and mental health benefits of green spaces are widely recognized, including their restorative and stress reduction potential. And that arises from a number of sensory experiences, so things you see, sounds you hear. And there's a number of features that are important. So, for example, the sounds need to have what's called soft fascinations. It needs to be able to keep your focus without direct attention. And it also needs to help you to feel this being away from the current situation, from your current thoughts and worries.
So what is a health-enhancing sound environment and how can they be created?
Yes, so there's three things we have to keep in mind. So first of all, sound has meaning. So sounds can be pleasant or unpleasant, eventful or uneventful, familiar or unfamiliar. And then we can categorize sounds into broadly three types. You have your nature sounds, like leaves rustling or running water or birdsong. You have technological sounds, like motorized traffic, machines, construction. And you have human sounds, like people talking. And in general, people perceive natural sounds as positive. People perceive technological sounds as more negative, more unpleasant, more annoying. And for human sounds is more complex. It depends on the situation. It depends on your state of mind. It depends whether you know these people. And the third thing to keep in mind is that different people have different needs depending on the situation. So the key to a successful design of a health-enhancing sound environment is to provide a diverse and varied environment. So, for example, you would enhance the natural sounds by, for example, providing water features and choosing vegetation to enhance the wind effect and also encourage diverse bird species. You would mitigate and minimize technological sounds, so either by addressing the source itself or by using distance, screening, site layout. And for human sounds, again, it's this concept of variedness. So if, for example, there's an area for social sports, which can be quite loud, quite vibrant, then making sure there's another area which is more secluded, more quiet, to encourage social quietness.
And what do you mean by quiet?
Yes, this is very interesting because when people use quiet, calm, silent, they often don't mean the absence of sound. So from an acoustic perspective, pure silence. What they mean is that they are able to hear the pleasant sounds. So for example, road traffic noise that is sufficiently quiet that you can hear the rippling sounds of a stream in a green space. So to some extent, again, it's this issue of being in control of your environment. You can choose the sounds you hear. And this concept of control is a very important element of the pathway how sound affects our health.
Thanks, Ben. So speaking of quiet, it's impossible to miss how quiet it was during the COVID-19 lockdown. Vehicles, aircraft, fixed plant and people noise were all significantly reduced. This created a unique set of environmental noise conditions and, as a dedicated community of scientists, we asked you to take part in a community data gathering exercise to capture this moment. To tell us more about what they did, here's Lindsay McIntyre, Director of KSG Acoustics. Hi, Lindsay. So what and who did the Quiet project involve?
So the Quiet project is a time-critical response by the UK acoustics community to the COVID-19 lockdown. So we asked the community of UK acoustic consultants and other acoustics professionals to undertake qualitative and quantitative data gathering during the lockdown. And we're going to ask them to repeat that again during October, November of this year, and then again next year, so during April, May, and October, November again in 2021, so that we can identify trends in the data. We've created a project website, which we've asked participants to create their own login on, which georeferences to their measurement location. We asked them to measure at locations that were safe during the COVID lockdown, and we'll ask them to use those locations again when they come back to the project again in a couple of months' time and again next year. The project's had some fantastic support from the acoustics community, but also specifically from the Institute of Acoustics, the Association of Noise Consultants, and the UK Acoustics Network, and we've been partnering with London South Bank University on the project as well.
How will you be able to use the results, and how will it affect us?
We've already started the process of aggregating the data from all over the UK, and as you can imagine, it's been quite a detailed process. We have a lot of different data points right across the country, including rural and urban areas. What we'll be looking at initially are average trends across various geographical areas. So, for example, we might look at average daytime, evening and nighttime values to start to get some headline trends out of the data. There are other certain aspects that might be of interest. For example, during the April and May lockdown period, the dawn chorus was a very prominent feature, and we realised that we've captured that across the UK, and that's something that we might look at as a separate small data set that might be of interest to perhaps the ecology community. There have been various suggestions of how the data might be used to support other research or even future policy development, and we've had a great deal of interest from other parties. So, for example, Transport Scotland and the Highways Agency, we've been in discussion with SEPA and also with DEFRA to see how our data might support their interests as well, which has been really rewarding. We've also had quite a lot of media and public science communication interest to see how we can present our data in the public realm. We're hoping that the research will further our understanding of environmental noise and how it interacts with other aspects of our lives. And we also hope that the interest that it's gathered will raise the profile of environmental noise and acoustics to the public and create a positive legacy out of what has otherwise been quite a challenging time.
Thank you, Lindsay. It was so quiet during lockdown that we can actually hear the birds singing again. And speaking of nature, there's a lot we can learn from it. To tell us more about natural sound absorption of moths and bats is Dr. Mark Holderreid from Bistow University.
Hello, Rich.
Hello, Mark.
But actually, it's Bristol University.
Oh, yes. So it must be time for my researcher's lunch. Bristol, obviously. So, moths and bats are able to fly stealthily. Why are they so quiet?
So it's all about this acoustic arms race that's going on, where moths try to avoid being eaten by a bat, becoming a bat's next midnight snack. And they do so by reducing the echoes that give away their presence to the bat's echolocation system. So being stealthy, producing weak echoes, is clearly a big advantage for these moths, because then they don't show up as strongly on a bat's biosonar.
Now, what is the Physics of Life grant, and how difficult is it to get funding for biological acoustics?
Well, getting funding of the magnitude that we got out of the Physics of Life grant is not an everyday success story. So the Physics of Life grant is very special because it does exactly what we believe we can contribute to. So the Physics of Life is, and I'm quoting from their mission statement here, they want to support internationally leading research that requires collaborative, interdisciplinary working to address key challenges at the interface of physics and life sciences. And we believe we are at this interface. We believe that the moth wings can tell us a lot about how to manipulate sound in very fancy and very advanced ways. And the way we think that we can contribute to our quality of life is that these moth wings are so much thinner relative to the wavelength and the sound manipulation they can do than anything we can do with technological sound absorbers, that by understanding how evolution has made these moth wings so remarkable, so remarkably efficient, we can design new and better sound absorbers for our homes and offices. And that's what this whole aspect of the physics of life is all about.
Thank you, Mark, from Bristol University. Now, here to tell us how normal materials can transform sound is Gianluca Mamoli from Spain. Hi, Gianluca.
What a mistake to make. I'm actually from Italy.
Yes, my apologies. My researcher should be sacked. So, what is your background and how did you come up with the idea that normal materials can be used to redirect and transform sound?
Richard, actually, I've been working in acoustics for more than 15 years now. But this idea comes from my experience as an amatorial thespian. When I'm directing, say, a pantomime, I can ask my light person, oh, I want a spotlight there, I want light to follow a character, but I cannot do that with sound, not with a cheap system. And cheap is the key bit when you do, well, amatorial theatre. And so I thought, wouldn't it be nice to have a do-it-yourself solution that you can put together and get the same effect? We have had that for ages for light. Wouldn't it be nice if we had materials that could do to sound what we do with light, considering that they are both waves? And so you take a normal material, which can be paper, or can be plastic, or can be metal or wood, and then you add a bit of engineering to it, you mix together, and you get something new. And that's what I do, this new bit. They're called metamaterials, which means beyond the normal materials.
Are they a new type of material? And how do they work?
It's all in the geometry. You take a material and you sculpt the inside. In a way, you take away materials instead of adding stuff. And what you take away controls the sound that arrives or goes through. And so that eventually a slab of plastic, like this one, might become a lens. So this is a 3D printed object, and you might see that inside there are different holes, and each of these holes does something different to the sound that comes from my voice. And actually this one focuses some particular frequencies to the side. So
how can this research be applied?
If you can get on sound the same control that you have on light, then you can transform a normal speaker into an audio spotlight. So into a beam which is directed like a lighthouse just to a specific person in a crowd. And then you can talk to that person or listen to that person specifically. Or you can imagine that you can build a projector that sends sound just to a person that moves, so that we have a small ball of sound here that follows us and we can listen to our private systems without headphones. Or you can imagine, if you can control again, you can also shape sound and so send sound around obstacles, but also you can cancel sound in a very thin thickness with very light materials. Designing new solutions for controlling noise in our hospitals might be one of the uses for our materials.
Thank you, Gianluca. To tell us how the Institute of Acoustics has been able to continue to support its members during the COVID-19 pandemic, here's Stephen Turner. Hi, Stephen. So how has the Institute of Acoustics been able to reach its members during COVID-19?
When the Institute moved to its new offices in Milton Keynes, those arranging it had the foresight to install some good video conferencing facilities using Zoom. And we were able to build on that to keep in touch with our members who suddenly find themselves isolated or on furlough. And it provided a means to keep in touch with each other. We organised weekly forum meetings on a Monday with no specific agenda, just invited people to drop in. And they did. We had about 75 as a maximum, usually about 40 or 50 each week. And what was interesting is I don't think we ever had the same people each time. And I think we reached out to about 200 or 300 members overall, discussing a whole range of matters, from work-related matters, how to cope with the government, grant schemes, through to acoustic issues and so on. And the membership seemed to enjoy it. What we also did was ran a series of what we called CPD refresher training, which were lectures of about 1 hour on a particular topic that is still currently relevant. So rather than asking the speakers to write a whole new talk, it was presentations they'd previously given either at an IOA one-day meeting or at an IOA branch meeting. And we invited members for free to attend this, and they have proved remarkably popular, not just in the UK, but we had members in Hong Kong, South Africa, India, and Canada. And they have proved, as I said, very popular. And although the sessions have finished at the moment for the summer, we are going to look to see if there is demand to continue them in the future.
Thank you, Stephen. And that deafening sound means it's time for Sound Flash, the headlines of acoustics discoveries. The Acoustics 2020 conference will now be held online. Find out more on our website. Data from a seismometer at the observatory show that measures to curb the spread of COVID-19 in Brussels cause human-induced seismic noise to fall by about a third, meaning the Earth's crust shook less as more people stayed at home. Scientists say trees have a role to play in combating noise pollution in urban environments and have identified the best species for the job. The larch was found to be the most effective tree when it comes to absorbing noise with its bark. Now, what flies and barks like a dog? A dog on a kite? No, some Airbus aircraft. The barking noise heard by passengers near the wing on an Airbus is actually caused by a hydraulic pump, also known as the Power Transfer Unit, or PTU. The purpose of the system is to ensure that minimum pressure is maintained across the hydraulic systems of the aircraft. Ella Lattenkamp and her colleagues at the Max Planck Institute for Psycholinguistics in Nijmegen, the Netherlands, trained 6 adult pale spear-nosed bats to imitate their own calls by bribing them with food if they repeated the sound, proving that bats, along with some birds, dolphins, whales and humans, are among the few species that can imitate sounds. With the increasing need for high-speed broadband comes the issue of overheating processes. Researchers from the University of Sydney Nano Institute and Max Planck Institute for the Science of Light have discovered chips using light and sound could be a solution. German Bundesliga broadcasts have been adding the sounds of a crowd to add atmosphere during the COVID-19 pandemic, replicating Dortmund Stadium's 81,365 capacity seating. They mixed the sound of a crowd recorded during a previous game with live sound recorded during that game. And then a Sky producer adds effects of specific sounds like that of the crowd during a penalty. According to a recent study published in the journal Scientific Reports, people with severe vision loss can less accurately judge the distance of nearby sounds, potentially putting them at more risk of injury. Calls are mounting for motor vehicle-free days in the Yorkshire Dales National Park amid claims record numbers of motorcyclists have descended on it as lockdown restrictions have been eased, ruining the protected area's tranquility. The Department for Transport has also confirmed it is considering the introduction of new powers to combat excessive noise from motorbikes. And that's it from the first edition of Sound Flash, bringing us to the end of the first episode of the IOA Video Bulletin. We're looking forward to sounding out some more exciting stories in the next episode, but until then, keep quiet and carry on. This programme was brought to you by the Institute of Acoustics, bringing our members and the acoustics industry together to exchange ideas, present new developments and network. Okay, right, are we done? Are we finished? Yeah? Well, no one said cut, so I don't know what's going on. Yeah, oh, my mic is on, is it? Oh, amazing. Well, God knows. I'd be surprised if they got anything after this. Right, I want to make sure that I get paid today. Okay, can you give me my phone? I'll get my agent on the phone. What? Where'd you put it then? What, someone's taken that? Who's that bloke? Why were there just dogs running around in the background? What was all that about? And what was that bloke on a unicycle around? I mean, this is supposed to be a professional set. Okay. I'm out of here. Have I got a car? No? I've got to get the tube. Brilliant. Thanks a lot.